All right, Year 10's last video for today, we'll look at example C. So when an equation takes this particular shape, when you've got brackets. So going back to our key ideas, this is the example we'll look at here when the function looks like this particular shape here. So x take some number. What does this number do, this h? We'll have a look at it in a moment, but I just want to draw your attention. This is more of a simpler version of the turning point form, which is right here. You can see it looks very similar, except with the major difference. There's a number here and here, all right? And you can see that when we have that particular function here, you can immediately locate the turning point by looking here and here. That's HK. They're just the numbers for the coordinates for the turning point. And then whatever that number is, that's the axis of symmetry on the x-axis. So it actually tells you where the left and the right are equal. But we'll look right here. And we're going to have a look at the specific example for question C. Let's see what it does. So y equals x minus 2 squared. There it is there. Now, I'll get rid of it. There's y equals x squared there. Now we can see, what does this do? You can clearly see it's the same shape. The only thing is it's just been shifted to the right. And so the number that we see inside the bracket, you can see that we've written x minus 2. When it's negative, when that number is negative, so negative 2, it moves to the right. All right, so you'll see if I write negative 3, it moves to the right to 3. Negative 4, it moves to the right to 4. When we have a positive, and again, yeah, this is counterintuitive. You'd think negative 4 would go backwards because you can see negative numbers on the left of the x-axis, but it works in reverse. It's a long story, but I'll explain it next week when we're in class. If we go positive 4, you can see that it now does move to the left. So it's counterintuitive, but it is what it is. Let's go back to negative 2. Right there. That position, which we call h, that 2 position just tells you how far across you've moved. So it's a translation left and right instead of up and down, okay? So previously, about a minute ago, I explained that there was a more sophisticated version of this equation where we could add numbers on the end. So let's see what that does as well. I'm sure we can figure it out. I'll just zoom in a little bit. Or I'll zoom out. There we go. That's what we want. If I go ahead and add 1, it moves it up 1 unit. What about 2? It moved it up 2 units. What about 3? It moved it up 3 units. Can you see the pattern here? Just like in the previous questions that we did, the number on the end indicates how far up or down you've gone from the origin. All right, plus 3. What about negative? I'm sure you can predict that. It's going to go down to negative 3. And so those positions will also tell us the positions of our turning point. So our turning point here, I'm just touching on the shape, is 2, negative 3, and that's clearly observed by looking at the function that I wrote in. The only thing you do is just you don't include that negative, right? So it's just 2. But then negative 3 becomes your y-axis coordinate. All right, let's now think of one last little point. And if I just remove that part there, we'll go back. What we can't currently establish with our current key ideas is the y-axis. We do need the y-intercept. So I can see if I touch, it does cross through at 4 on the y-axis. But what we're going to practice is substituting when x equals 0 into the function, right? When x equals 0, that tells us where our y-intercept is. So let's go to that question now, and we'll actually just do it and practice it. So graphing or sketching this particular function, we know it's upright because there's no negative sign in front. And we know by looking here, it's translated or moved 2 positions to the right from the origin. Is there anything else we can ascertain or understand? The last thing that we need to understand is the y-intercept. Okay, so let's do that. The y-intercept is found when x equals 0. So when x equals 0, y equals, and we will substitute x for 0. There we go. And so let's do that. 0 minus 2 is negative 2. And negative 2 squared, well, that's negative 2 times negative 2, which is positive 4. Okay, and you can see that right here. That's exactly what's happened. So let's just quickly practice drawing it, and I'll draw it just down to the right here. This. I'll make that a little bit longer, I think. There we go. Like that. Draw our arrows. Here's x. Here's y. And we'll label the axes just to get some accuracy here. So let's label that 2. That can be 4. That's 3. That's 1. Roughly. There's 1. There's 2. There's 3. And there's 4. So what we do know is the y-intercept is at 4. We just established that when x equals 0. So I'll use a green line. And let's put that there. What else we know is that because of this number here, we know that the graph has been pushed or translated to the right 2 positions. So the turning point is going to be right here. All right. Again, there's no number on the end like +4, so it's not going to be moved up. So the turning point is just going to be on the x-axis. It's not going to go up here somewhere. It's just going to be on the x-axis. So we have all the information that we need now. We just draw it. So draw a shape. Here we go. It looks a little bit pointy to me, but I think it's the curve is hidden behind the large circle that I've got here. So I'll try and make it a little bit more curved. There we go, like that. I think that's a little bit better. The line on the right-hand side is a little bit dodgy, but make sure you get your arrows in, and we write in that at 4 and 2 is our turning point. And that's how we do those questions. So have a go at the questions that are in the book that I emailed you out today, and email me back if you have any questions.